Good day, everybody. So looking a little bit at what this cosine law is all about. We're going to start off with something that we already knew, which is the Pythagorean theorem. The key here is a little bit about labeling. We use capital letters for the corners and lowercase for the side lengths. And it's also opposite to that side length that we label the lowercase. So in the Pythagorean theorem, we know that c squared was equal to a squared plus b squared, which in this case is going to be c squared is equal to 24 squared. Let's 24 squared plus 20 squared. And that's going to be equal to 976, which we would square root both sides to get that c is rounded to about 21.24. That's not right. It's got to be the longest side, 31.24. Okay. Now, when we're talking about the non-right triangle, then life takes on a little bit different because that hypotenuse, which is no longer called the hypotenuse, is going to be a little bit shorter, right? Because it's kind of folded in. Kind of makes sense if you try drawing it or measuring it by itself. So we would start off exactly the same way. C squared is equal to a squared plus b squared. But to make up for the fact that this is not a 90 degree, we're going to be subtracting a term, which is 2ab cos c. Now, that idea of cos c refers to the angle, and let's say this is 85 degrees, okay, so a little bit less than 90. And this term is basically going to take up the slack, okay? It's going to say, wait a second, this is actually not really a 90, so we got to adjust somehow. And so we would still get kind of the same thing, right? C squared is equal to 24 squared plus 20 squared. And the key element, by the way, is that the C is actually sandwiched between the two sides A and B, and corner capital C. And I refer to that as SAS, side angle side, the angle between two sides. So 2 times, and the order of operations is really important here. So hopefully your calculator is going to take care of that properly for you. And make sure when you're computing the cosine of C that your calculator is in degrees. So giving you some details here, this is going to be equal to the same 976 as before, but then that extra 2, 24, 20 cos C is going to wind up subtracting 83.67. And so we see that we're going to be actually taking a smaller amount, the square root of a smaller amount. So let's work this out quickly, 976. And notice I've rounded that 83.67. You would use the full calculation number in your calculator. 892.33. So it's a little bit smaller than that 976. Square root both sides. And you're going to get the C is equal to second square root, second answer, 29.87 after rounding to 2 decimals. So this is approximate amounts for both of those answers, and they're in meters. So that's how it works. Let's pause this for a second. So taking that previous result and my really bad drawing here of the triangle, we can actually find out the lengths of the angles, measure of angle A and angle B. And again, remember capital letters for those corners. The way the law of sines works is you just take the sine of any angle over the side length that is opposite. So in this case, sine A would be opposite the 20. And then you have to take a fraction where you know both of the values. And so I'm going to use the C, which I now know sine of 85 degrees, divided by 29.87. Notice, by the way, these fractions can also be upside down, both of them, for this to work. We do a crazy cross multiplication here. So I'm going to get 29.87 sine A equals 20 sine 85. And before you do any calculations, let's isolate the A completely. So first I'm going to get the sine A by itself, which means I'm going to divide that 29.87. And you're supposed to put that 85 in brackets, by the way, underneath. And then we just do the calculation of the whole thing. I'm going to leave sine A for this for now, and then we're going to use the inverse sine later. So we just type this in the calculator. Make sure to press equals before you do the divide by 29.87. So 20 times sine 85, close bracket, equals, and then I'm going to divide by 29.87. And you're going to get a stupid looking number like this, right? It's the sine of an angle. 0.6670, and I'm going to put a lot of the decimal places. We want to keep that in the display, and then we're going to have to do second sine on the calculator to undo the calculation. So if I'm looking for this, it's going to go on the other side. A is equal to the second sine, the inverse sine of that number that we just got. So second sine, second answer, boom, is going to give me 41.83. And you say, what is that? Well, this is the angle measure. So this is in degrees. Whenever you take the inverse sine of something, you're going to get an angle in degrees. So that means that the measure of this angle is about 41.8 degrees. A lot of the time we'll round it to just the nearest whole number, but I'll keep the whole number. And then we can find the angle of the third one by just subtracting from 180. Because we know that the sum of the three angles is going to be 180 degrees. So I hope this helps a little bit with the calculations. The law of cosines does have another little complexity where you're looking for the missing angle. And that's basically, if you go back here, if I gave you all three side lengths and you're looking for the missing angle, you would have to isolate the 2AB cosine term. If you want to see more of that, you'll have to just send a request. Thank you, and I hope this helps.